Well, I hope you're ready to tackle some big-time trig questions tonight, because we're going to take another step closer to that elusive 100 on the Regents exam as we take a look at two particular topics. First of all, the first half of the video, we're going to focus on trig forces. We're going to draw that parallelogram, review the properties of a parallelogram, and use the law of cosines and sines to find the missing forces and such. And then we're going to change gears and we're going to review how to find the sum and difference of two angles and just picking out the appropriate formula and talk about why we're not allowed to use a distributive property. So let's go jump in. So when we first start to talk about forces, we kind of have to imagine those two tow trucks that are both hooked up simultaneously to a car in the ditch or something. And so what we'll do here is I'm going to try to create some arrows here to represent our forces. Let's see here, we might have to slide that bear over a little bit. Okay, so what I want you to imagine is that we've got some object right here. And what's happening is we've got two forces acting on it, one pulling in this direction and then another one pulling straight east. And the length of these vectors, each of these lines is a vector, and the length represents the magnitude of the force they're pulling with. And what's happening is we see the first half of a parallelogram, and so we're going to go ahead and finish drawing that parallelogram. And what you'll notice here is that opposite sides are congruent. That's the first major thing. So for instance, if this side had a length of 20, then the opposite side would guarantee to be 20. Or if the bottom side was, say, 45, then the top side would also be guaranteed to have a length of 45. Now here's perhaps the most important element that we're going to talk about, is that this angle down here is supplementary with this angle up here. So for instance, if we knew that this bear right here was, say, I don't know, 50, then we know that this obtuse angle up here would be 130. So you're guaranteed to have an acute angle here and an obtuse angle here, and that those two angles definitely add up to 180. And I'll throw one more thing on the pot here. We're always going to have this thing called a resultant, which is the path that the object's going to take as those two tow trucks are pulling it. That does not bisect this lower angle right here. So it doesn't, just because the acute angle is 50 doesn't mean it splits it in half into 25 and 25. In fact, we're probably looking at something like 30 here and then a 20 down here or something similar to that. So let's go ahead and jump in. So just like any other word problem, we want to read it carefully, get a great diagram drawn, and then label it as accurately as possible. So we're talking about two forces, and as soon as you see that word, we're going to instantly draw our parallelogram. Alright, so we're looking at something like this. And I'm always going to assume that the lower left-hand corner is where my object is. And let's see, we've got an angle of 65 degrees between the two forces. And I'll throw a little degree symbol in there. And the forces measure 22, so I'll throw 22 on the shorter one. Then I'm going to throw 39 on the bigger one here. And they want me to find the length of the resultant, which is going to, that's just a fancy name for the diagonal. And so I'm going to use a green line here to represent my resultant. And that's what I want to find the length of. So the first thing is, I know that the opposite side is guaranteed to be 39, and the most important move is finding the measure of this obtuse angle. You don't want to use the acute angle here. So we're going to do 180 minus 65 in our heads, and that's going to hopefully give us 115 degrees. And now I think you're going to see a pattern here. We've got a side, we've got an angle, and we've got a side. And anytime you see side angles, whoops, scratch that, side angle side, we're going to use the law of cosines for sure. That's a guaranteed fact every time we get side angle side. So let's see if we can set that up. So let's put an X right here, and this is a great time to hit that pause button before I start to show any of my work and see if you can set up the law of cosines and evaluate it on your calculator correctly. So I'm going to say that x squared, because that's opposite the given angle, is equal to 22 squared plus 39 squared minus 2 times 22 times 39 times, not the sine, but the cosine of 115 degrees. So it's a good time to just kind of tap that mode button on the calculator, check, make sure it is in degree mode, and then what I want you to do is I want you to type in this entire string all at once, okay? Don't try to do it in pieces, just do it all at once very carefully. We'll get it right the first time, we'll hit enter, and then the next thing we're going to do is take the square root of that number. So I had that 2,730-ish, 0.212937, yada yada, and then I took the square root of that number, and I got, and I think they wanted nearest, let me double check that. Well, they didn't really say in the direction, so we'll just say nearest Newton, and I had 52.25, so I'm going to round that just to 52. Get this under control here. All right, so we say 52 newtons is the magnitude of the resultant force. All right, now we do have a part B to this question, so let's go see what that says. So I drew a new diagram and I carried over all the information that we had, including the angles and the lengths of all the sides, and including the resultant that we just found at 52. So now they want me to find the measure of the angle between the resultant and the larger force, which would be the 39-pound force. So they want me to find this angle right here. That's the rascal that I want to find. And of course we do have the alternate interior angle principle here, so that angle would be equivalent to this one right up in here. So that's the one I want to try to find. I'm going to call that my theta. And what I'm going to do here is I'm going to use the law of sines, and I'm going to focus on who's opposite of who. And of course, just like in the first half of the problem, if you forgot the law of cosines or you forgot the law of sines, it's not something you have to memorize. It is on our reference sheet. And so as far as the opposites go here, I'm going to say that the sine of 115 degrees, and of course who's opposite of that, that would be the side that has a length of 52, is equal to the sine of theta over, now remember, who's opposite of theta, that would be the 22 right here. So now all I'm going to do is I'm going to cross multiply 22 times the sine of 115. Again, hopefully you've already tried this on your own. You've already hit the pause button, and now you're just kind of waiting patiently to see if your answer is correct or not. And then I'm going to divide by 52. So if this part right here is boring, then you're in great shape. You're exactly where you want to be going into the exam. Now here comes the interesting part. This last move is very important. So I typed all of this into my calculator, and I got 0.38, 34, 37, yada, yada, yada. And of course that goes on forever and ever, equals the sine of theta. My very last move here, because I'm solving for an angle, is I'm going to take the inverse sine of that. And I'm going to round to the nearest, I'll say 1/10 of a degree. I don't think the direction's really said, but we'll say the measure of angle theta turns out to be 22.5 degrees. And that seems like a very reasonable answer based on the diagram that we had drawn. So here's our last forces problem for the year, and I'll tell you what, this is the ultimate challenge. If you can set this one up on your own and solve it successfully, then you are in tremendous shape. But anyway, so after you hit the pause button and try it, come on back and see if you agree with my setup. So the first thing I did, again, as soon as I saw that word forces, I knew that I was going to be working with a parallelogram, so I just went ahead and got my drawing out of the way. And we have a resultant this time, so they're changing what they're giving me. They're giving me a resultant that has a length of 70 pounds. And one of the other forces is 50, and they didn't say which one was 50, so I guess I'm going to slap the 50 on this one, but you could have easily done it on the bottom one, and your diagram would have looked a little different, but we'd end up with the same answer in the end. And that forms an angle of 67.40, so just this angle right here is going to be 67 degrees 40 minutes. Alright, with the result. Now, they want me to find to the nearest pound the magnitude of the other force, so I'm going to put an X on the other force, and of course we know that opposite sides are congruent. Now, like I said, I thought this was the ultimate test, and I find this one to be very challenging. What you need to do is we need to see this pattern right here. Side, angle, side. So what you've got here, and don't be afraid to label this in your notebook, you've got your side, and then immediately following that you have an angle and then another side. So once again, we have that side angle side pattern, and we're going to jump on the law of cosines. And it's going to work out beautifully here. So how am I going to set this up? I'm going to say something like, let's say that x squared is equal to 50 squared plus 70 squared minus 2 times 50 times a 70 times the cosine of, and this is going to be a barrel of fun trying to type this in, 67 degrees in 40 minutes. And of course for that degree and minute sign, we're going to go to the angle menu, which is just above the at button. So let's type in that entire string all at once and see what we get. So I got x squared equals 4740 and change, dot, dot, dot. I stored it, I took the square root, and I got the other forced. I had 68.8, so I'm going to round to the nearest integer here. That turns out to be 69 pounds, which I believe they were using pounds instead of newtons on this one. So there you have it, ladies and gentlemen. That's everything you need to know about forces. So let's switch gears and go talk about the sum and difference of two angles. This sounds really foolish, but the first thing I want you to practice is just practice pronouncing this out loud. So how would you read this to a friend of yours, over the phone, or if you blindfolded them or something? How would you read it to them so that they wrote it down correctly? And what you're going to hear yourself say is the sine of the quantity angle A plus angle B. All right, and what's happening is whenever you use the word of, and it doesn't matter whether you're working with trig functions or log functions or whatever, the word of implies that we are not going to use the distributive property. All right, that is a big no-no. So we're not using the distributive property because of the word of, and that's the first thing we want to stress. We're not using that. We have to, when we see this, we have to recognize the need to go to the formula sheet and use one of the very special formulas for the sum or the difference of two angles. This type of question is becoming more and more prevalent on the Regents exam, and it is one of my favorite ones. I've really grown to like this type of problem. And what you'll notice here right away is in these parentheses here is we've got two angles. We've got angle A, which is 270, and then you've got angle B, which is represented by X. And they want me to simplify this the best that we can. So certain parts are going to clean up really nice and other parts might not. But first thing I'm going to do is I'm going to dig through my folder and I'm going to pull up my reference sheet right now. And again, go ahead, try this problem. Make sure, I wouldn't be surprised if you get at least 90% of it right all on your own, and then come on back and see if we set it up the same way. So my reference sheet looks like this. And let's see, I'm looking for the sum of two angles, and I need to use cosine, so I'm going to use this formula right here. I'm going to be very careful to make sure I get it right. And every time I see a capital A, I'm going to substitute a 270, and every time I see a capital B, I'm going to substitute an X. So it's going to look like, let's see, the cosine of 270 times the cosine of X minus the sine of 270. Now, they could have used 3 pi over 2 instead of the 270, but they didn't. They happened to use just the degree value. All right, now as far as cleaning this up and evaluating the cosine of 270, what I want you to be able to do is to draw or visualize the cosine curve and identify where 270 is. 270 lives right there, and the height of the curve at that moment is a 0. And then what's going to happen is we need to do 0 times the cosine of X, which then turns out to be 0. Now I also want you to be able to visualize the sine of 270. So I'm going to draw this curve here. I'm going to identify 270. The height of the curve at that moment is -1. And then I'm going to multiply by the sine of X. And actually what we're getting is plus sine of X because we had two negatives. And 0 plus the sine of X is indeed just the sine of X. So that is my simplified answer. And a lot of times that's what's going to happen is you're going to get fun numbers like 0 and -1. And it's going to cause things to clean up really, really, really nice. Well, it's very fitting that we saved this particular problem for last. Just a few years ago, we had a very similar problem on the Regents exam, and it seemed like this was the one problem that stood in the way of so many people getting a perfect score. This was the one problem that kept them from that elusive 100. So I challenge you to not let that happen to you. If you're going to get stumped by a problem, don't let it be one of these sum and difference questions. So first things first, when they throw this word at us, what does that mean to you? Why is that word so special? Well, what it means, first of all, is we're not going to use a calculator, okay? No calculator. Because what happens is the calculator is the opposite of exact. The calculator, as far as the decimal values are concerned, gives us approximated values and not exact. The other thing that the word exact means to me is that I should expect to see radicals. All right? Expect to see radicals. And if you don't see radicals, yet they use the word exact, then that's kind of a strong indication that maybe we're on the wrong path. So expect to see radicals. And what we're going to do is I'm going to rewrite 15 as 45 degrees minus 30 degrees. And I think you'd all agree that 45 minus 30 is equivalent to 15. So I haven't done anything wildly illegal or anything like that. And then what I'm going to do is, because I'm subtracting, is I'm going to go to that formula sheet again, and I'm going to look for the difference of two angles. And 45 degrees is going to be angle A, and 30 degrees is going to be angle B, and we're going to make all the appropriate substitutions and see what kind of cleanup we get. So I've kind of imported my little cheat sheet here, and I'm specifically looking at that first formula on the list. And I'm going to substitute a 45 for A and a 30 for B. So I've got the sine of 45 degrees times the cosine of 30 degrees. Again, the parentheses are optional here. I just prefer them because I think it helps kind of organize my thoughts here. Cosine of 45 degrees times the sine of 30 degrees. And now it just comes down to those flashcards or those values that we memorized, earlier in the year. And we're going to get a good test here. Let's see, the sine of 45 is just radical 2 over 2 times, let's see, cosine of 30 is going to be radical 3 over 2. Cosine of 45 is radical 2 over 2, and let's see, sine of 30 is my favorite one, that's just 1/2, and of course we're multiplying. Great review with multiplying fractions here and radicals at the same time. We're going to multiply the numerators together to get radical 6, and then the denominators give us a 4. Again, numerators give us radical 2, and the denominators give us a 4. Notice we do have common denominators. That is something that should happen every time we do these problems. So we can combine two fractions into one fraction, yet the numerators are not like terms. So although I do have one fraction, it's simply radical 6 minus radical 2 all over 4. That, ladies and gentlemen, is the exact value of the sine of 15 degrees. So there we have it, ladies and gentlemen. You're one step closer to that elusive perfect score on the Regents exam. We wish you the best of luck. You've worked hard all year. You certainly deserve it. We'll talk to you later. See ya.